Okay, so this is our first objective from our new unit, quadrilaterals. Quadrilaterals, if you break it down to the root word, quad means four, so this is our unit on four-sided figures. Alright, so all of the objectives in this unit are going to be on different four-sided figures, and the first quadrilateral that we're going to talk about is parallelograms. Right? A parallelogram is a quadrilateral that has both pairs of opposite sides parallel. So if you look at parallelogram PQRS, you can see that the opposite sides are indicated by the tick marks that they are parallel. So QR is parallel to PS, and PQ is parallel to RS. And again, these little arrows show our parallel sides, and because there are two sets of parallel sides, we have two sets of different looking tick marks. The other thing we need to know is how to label a parallelogram. So just like we used to call triangles when we had a little triangle symbol, we also have a little parallelogram symbol, and then you need to go around the parallelogram in order. So you could start at any vertices or vertex and just go around the quadrilateral. So if we want to start at P, we can have parallelogram P, then we go to Q, then we go to R, and then we go to S. Right? But really it doesn't matter, there's a lot of different ways to name, so we could also start at R and work around the other way and go to Q, to P, to S. Alright, so it doesn't matter where you start or which direction you go, as long as you go in an order around the perimeter of the shape and you're not cutting through and hopping around from vertex to vertex. Alright, so what our main focus for this objective is the properties of parallelograms. We have properties of size for our parallelograms, properties of angles for our parallelograms, and properties of diagonals. Properties of the size. If a quadrilateral is a parallelogram, so if we have a four-sided figure and we know that it's a parallelogram, then we also know its opposite sides are congruent. So if we have our parallelogram tick marks, we know it's a parallelogram, and once we know that it's a parallelogram, we can then assume, okay, my opposite sides, the longer opposite sides are congruent, and my shorter opposite sides are congruent. We have properties of angles. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so just like we had opposite sides, we also have opposite angles. So again, if we are told that it's a parallelogram, we know that the opposite sides are parallel, then we can also assume that the opposite angles are congruent. So if I have this angle congruent right here, then I know that the opposite angle is going to be the same measure. And this angle over here is going to be opposite and congruent to the blue angle down at the bottom. All right, so that's one of our properties of angles. We also have a second property of angles, and this goes back to the idea of parallel lines and transversals. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. All right, so we can go back, we know that these lines are parallel, and this line is our transversal. We know a lot of things with our parallel lines and our transversals. Alternate interior angles, alternate exterior angles, vertical angles, but then we also learned about our corresponding or consecutive angles. Consecutive angles are the two angles that are both inside of the parallel lines and on the same side of the transversal, and those two angles added up to 180. All right? Well, really, we have the same situation here. This is parallel, and it's kind of like this side is a transversal. So if we extend these lines, there's our transversal, here's a set of parallel lines, here's a set of parallel lines. So the interior angles of the parallelogram, this angle right here and this angle right here, those are consecutive angles. so that we know the consecutive angles are supplementary or equal to 180. Now, because we have two sets of parallel lines, both the top and bottom and then these sideways parallel lines, we can get multiple sets of consecutive angles. So angle 1 and angle 2 are consecutive angles in this diagram, but if we look, angle 1 and angle 4 are also consecutive angles because technically these lines are parallel as well. And so we can consider this the transversal and these the parallel lines. Right. So make sure you have this angle property in your notes, but we're definitely going to spend more time on this in class. The last property is that the property of the diagonals. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So if we go ahead and draw our diagonals in on this parallelogram, there's a diagonal from P to R, a diagonal from Q to S. The diagonals bisect each other. Basically says that the diagonals are cutting the other diagonals in half. So this diagonal is cutting this diagonal in half. So now I know that this part of one diagonal is congruent to this part of the other diagonal. And QS is cutting PR in half. So these are congruent to each other as well. So those are our four basic properties of our parallelograms. Let's do two examples. Make sure you get all of their properties down in your notes as well as the example. So for example 1, they want us to find the values of x and y. So we have tick marks. We know this is a parallelogram, so what can we assume given a parallelogram? Well, if I want to find x, I see that x is involving an angle measure. And what property do I know that can help me find x? Well, 2x and 50 are opposite angles, so we know that they are congruent. So we can set 2x equal to 50, solve for x, and we find x by using the property of angles that says opposite angles are congruent. We also know that if we want to find y, we have the other measure of the side, and we learned that opposite sides are congruent. So this side is congruent to this side, and therefore 18 is congruent to y plus 3. So to solve for y, we subtract 3 to both sides, and we found y by using the property of parallelograms that says opposite sides are congruent. The second example wants us to find these various measures given this diagram. 2 is the measure of Kn, NMJ is 30 degrees, and KJM, the entire large angle, is 110 degrees. If we want to find NM is this part of the diagonal right here. We know that JL is cutting KM in half, which means this NM has to be congruent to KN. Therefore, NM has to be equal to 2. So then they want us to find KM, which is the length of the entire diagonal. So we can just add up those two congruent pieces. 2 plus 2 is 4. And that is using the property that the diagonals bisect each other. And now we're going to find the angle measures. They want us to find the measure of JML. So JML is this angle over here. And we can use the fact that J and M are supplementary angles because they are consecutive interior angles in this parallelogram. So I know that 110 plus whatever JML is, we can just call that x, has to equal 180 because they're consecutive interior. We solve. So this angle has to be 70 degrees. So that's our entire angle, JML, is 70. But then the diagonal is kind of cutting that angle in half, and we know that this piece is 30. And they want us to find KML, which is just this upper portion up here. So again, we can use the sum of two angles. We know that 30 plus that missing angle has to equal 70. We can solve for our x by subtracting, and x equals 40. Alright, so there are our properties of parallelograms. Make sure you come with your notes and are ready for class.